Hey, 11th graders. We are moving on to talk about what the main idea of this unit is, which is linear modeling. This unit is called linear modeling, and this lesson is called linear modeling. So we're just going to kind of take our first toe dip into the water that is talking about modeling. We will be doing modeling with much more than just linear equations. We'll talk about quadratic modeling, we'll talk about exponential modeling, we'll talk about sinusoidal, which is your trigonometric functions, sinusoidal modeling. So this is our really our first unit to deal with modeling. And as we're starting to get closer and closer to learning about IAs, you will probably sometime soon begin your first practice IA. It's a very good topic for an IA to model something that you're seeing in the real world. If there's something that you enjoy or are passionate about, there's always something you can model in terms of a relationship between two variables. We're always trying to create relationships between two variables. Does the time that I wake up affect how I feel in the day? Does the amount of time that I set for me to do homework change how well I do on homework? Right? We're always trying to create a relationship between two variables, and that is what modeling is. It's taking a real world situation, taking two variables and saying, what if I create a bunch of, or gather a bunch of information about these two variables, the amount of time that I spend on a homework assignment compared to the grade that I get on it, and you take all that information and you create points, and then you create a model, which is just a fancy word for an equation, to accurately represent the pattern that is happening in the real world. And that's all we're trying to do here is recognize patterns, see them, see that there is a pattern, figure out what the pattern is, and then can we turn it into an equation in order to better predict what's going on. All right, so let's go ahead and delve on in. In a chemistry experiment, a liquid is heated and its temperature is observed. The graph shows the temperature of the liquid, which is uppercase T in degrees Celsius, for lowercase t minutes after the experiment starts, up to the end of the experiment. There are two variables here, uppercase T and lowercase t. That happens quite a bit where you'll see that we have an uppercase as one variable and a lowercase as a different one. This is your X and then your Y. I think it's really important, and I'm sure you've heard math teachers. I'm sure I'm not the first math teacher to tell you this, but I want you to really think about it for a second. It is really important to write down and label your variables at the beginning of a problem. Because as you've seen in math problems, especially with things like this, like word problems, there's so much information and so many processes that you're trying to keep in your brain and you're trying to figure it out. And if you're somebody who likes to just kind of sit there and think about it and figure it out and be like, okay, I think it might be this, and you don't like to write down your work, what you're doing is you're taking this variable, you're taking this variable, you're taking this information that was given to you on the page, you're taking what you've learned 2 years ago from a different math class, and it's represented as these little objects, right? There's like a million different things that you're trying to keep track of, and then you start juggling it. And the more balls that you add to your juggle, the harder it is to keep track of everything. You forget them, they drop, right? You become not a very good juggler. If there's anything that you can take out of your brain and put on the page, you no longer have to keep track of it because it's there on the page and it's kept track for you. So if you can take your label of your variable, T equals temperature, oh, that's in degrees Celsius, lowercase t is time, which is represented in minutes. If you could at least do something like that, which takes your information and puts it on the page, you no longer have to worry about it anymore. Because when you're like, oh wait, what is my X variable again? Oh, that's right, it's time, it's T, it's time, lowercase t, time. So it's going to be important because as you get into this interpretation of modeling, when we talk about modeling, we're comparing it to the real world. So that means that we're taking real world situations and applying them into equations, but we're also taking equations and saying, okay, well, what does this mean in regards to the situation we're talking about? What does this mean in regards to the temperature? So you have to know, oh, this Y spot is temperature. So then this number that I get is regards to temperature. So what does it mean to be a 0 in temperature? What does it mean to be a 60 in temperature? And that is what we're going for here. So it's important to know what your variables are. I think it's really important to label them. State the length of your experiment. I want you to look at this graph right here and notice a few things. We've got a line, which is cool. We're talking about linear models. At the end of the line, you know that lines continue on if they have arrows at the end. We do not have arrows at the end. We have dots at the end. Notice those dots right there. And they're telling us, hey, this is the beginning and end of our line. In other words, it's a segment. So this is the only space that we're focusing on. So you can even talk about the domain. The domain is between 0 and 10, including those values. But this is the extent of our experiment. So when it says state the length of the experiment, you have to think length. That's time. Oh, time is our x-axis, lowercase t, time. So for how much time does it extend? Notice this connection. It's important to write things down because it helps draw those relationships for you sometimes. What is the length of this experiment? How long does this experiment last? It lasts 10 minutes. If you just wrote 10, realize you could be like 10 days, 10 hours, 10 years. How long does this experiment last? 10 minutes. Okay. Estimate the initial temperature of the liquid. Initial always means at the beginning. Initial always means time equals 0. That's what it's telling you when it says initial. So it says, hey, when time equals 0, what is the temperature? So you look at your graph. Time equals 0. My temperature is right here. Units of measurement can be tricky sometimes. I know it's 2 tick marks up on this bar, and I know that there's some amount of tick marks that get me to 80. So maybe it's every 10, or maybe they're 5, or maybe they're 20. I don't know. I have to go in and count how many tick marks are there. So I count 1, 2, 3, 4, 5, 6, 7, 8. Oh, for 8 tick marks, it gets me to 80, which means 80 divided by 8. Each one of those tick marks was 10. Right? We're going up by 10 there. So if we're up to the second tick mark, that means that your temperature is 20. 20 what? Degrees Celsius. Your initial temperature. So this means temperature of what? Temperature of this liquid in your chemistry experiment. The initial temperature of this chemistry liquid is 20 degrees Celsius. That is, I believe, at about room temperature. Celsius is not like the natural temperature feeling for me. So like I know what like about room temperature would feel in Fahrenheit, and I know that that's below my body temperature, but not ridiculously so. So I'm pretty sure that's like room temperature. Does that make sense? Okay, we now want to estimate the rate of change of the temperature of the liquid. There's lots of ways that we can do this, but I would recommend with a line not counting, because our units of measurement here are way different, right? We jump by 2s here, we jump by 10s up here, sometimes by 80s, right? So what I would do instead of just going like, oh, I go up 1, 2, 3 over 1, 2, you can create 2 points or find 2 points on this graph and then use your formula. We already have 1 point. The first point that we have is this information right here. This information tells us, hey, there's a point at 0, 20. So that's 1 point. Then I'm going to go ahead and grab a point that looks easy to grab. I could grab a bunch of them, right? You can see that there's like places where we crisscross on these x values and the line goes right through there. So that would be a good point. That would be a good point. This, however, is a really nice looking point because it's at 2 and 80. So that's an easy find for me. So that's why I'm grabbing it. That's it. I just know that I need 2 points in order to go ahead and find my slope. Hey, go ahead and find your slope.